Yeah. All right. So welcome back to the second day. Yesterday, I hope I could show you some potentials or some motivations why you do this, and show you some ways how to get data and probably how to make graphics or even maps. Today, the first half of this day, I want to add some tools that you need in order to work with spatial data and in order to extract probably some more variables that you can use in your analysis. And so I will show you how it's done with different tools, and then you can replicate it yourself. It's all on the slides. You have the slides in the folder, and you have the necessary data in your folder. And then I will show you some shapefiles from Ukraine that I downloaded yesterday evening that you can probably use. And the next half of this day we will go into spatial statistics. Alright, so maybe I should add something that was probably not communicated well enough yesterday. First thing, well, not first thing, but when you have this geo-referenced addresses, then what to do with it, and that's quite easy because I mean it's not in a shapefile yet, but it's in a comma-separated file, and you can easily import these comma-separated files and save it as shapefiles. So this your colleague did it yesterday already. This is something that you always do with the layer menu, and then you can create or add layers based on very many different formats of import formats, and the one on the bottom, add delimited text layer, that's like the possibility to add all your georeference data. So you can try it if you want, but it's really not so complicated. Okay, so we start with the different tools that you probably need when you. Oh, I always have to switch between my PowerPoint slides and. Or do we need a short break? No?
Sir?
No, everything's all right?
Yes.
Okay.
Да, везде флешки.
Это уже шестовазилось?
Да. Папа точно.
Okay, first thing I talked about a lot of the time was that you need the same coordinate system in all of your shapefiles. This is probably not so relevant at the moment because you get all your data from the internet, but sometimes you get data from other sources. And this is pretty easy. Yeah, that's what I already said, and it's pretty easy because you change the coordinate system by saving it as a shapefile, as a new shapefile, and then you can specify the coordinate system. So I can show it to you. We have, for example, the neighborhoods shapefile that you already saw, and you would right-click on this neighborhood shapefile and save it as a new shapefile, and here you put this coordinate system. You can choose between hundreds and thousands of different coordinate systems. So it's usually good to use the VGS 84 shapefile, but it might be that your shapefiles have different coordinate systems. So then you choose this 3857 EPSG shapefile number, and you're good to go. So we don't have to do it because it's already in the correct coordinate system, but I just want to show this to you. Okay, next tool that we need is the field calculator. So usually we manipulate data in our statistical programs like in SPSS or somewhere else, but for small and even for bigger kinds of manipulations you can also do directly in your QGIS program. And like the example would be now that we calculate the share of foreigners in these different neighborhoods that we have. As we already said yesterday, it's probably not so interesting to make a map of the amount of inhabitants or the amount of foreigners, but it's more interesting to have the share of foreigners. And that's again not very complicated. You have to open the attribute table, and here you find very small here, but I highlighted it on the slide so you can have a look at the PDF. You have the red circle, this is the button you have to click on, and this is the field calculator. But when you hover over this icon with your mouse, then it says Open Field Calculator, and then you have a lot of different possibilities that you can use. And what we want to do is to create a new field, which is a new variable. But we could also write the manipulated data in an existing field or an existing variable. So that's up to you. You have to give a new name of the field. That would be something with like share of foreigners. As with a lot of programs, you shouldn't use more than 8 characters in your variables, and you should use only the English alphabet probably. But you can try otherwise, but it might run into troubles later on, so it's always a good thing to stick to 8 characters. Okay, and here you have a lot of different functions that you can use, and you write them here in the left field. When I would write here like 5, then it would fill the whole field with number 5. So, but this could also be sometimes useful, but not now. But we want to do a very easy thing. This would be I'm searching for the field and values, and if you open this, then we see all the fields that we have already, and we can and as we want to calculate the share of foreigners, we divide the number of foreigners by the number of inhabitants. I just double clicked on it, and then it fills into this field, and I click on OK, and it didn't work, unfortunately. Okay, I will try again. There was probably I know the problem is. You see, we have here inhabitants, and we have.
But it should be placed in a new variable.
Yeah, it is. Create a new field. But we have to specify a different output field type. Now I said it should be integer, and integer of course is either 0 or either 1, which is unfortunate when you want to compare when you want to calculate proportions. But you have to specify that it should be a real type with decimal numbers. Now when we do it like this, and now second field, and so we see now it worked correctly. So this is sometimes it's the easiest way just to to calculate simple statistics within your spatial data. So now you probably can delete this column, or maybe we can't. No, we can't. Okay. This is probably a good moment to show you one of the extensions that I told you about yesterday, which is the table manager. And with the table manager you can manage the fields that you have. And now we have this field. Do you see the table manager? Table manager. And when here you see all the fields that you have, and because I know this field share F, share of foreigners, is empty, or is not empty, but it's not meaningful because I made this mistake. I can just delete this field. Yeah, no warning, and then I can save it again, and so now I have a cleaner shapefile than I had before. So everything all right? Okay, so there was no question. It's like in an auction when you do it like this, then you bought the car in the end. Okay, so you can do whatever you like with this field calculator, but for like the calculation of shares, it's probably easiest. And then you can, again, as we did tomorrow, I can open properties, style. I'll have the graduated categories. I classify it in equal intervals and I apply it. No. First I have to select the share. Like this, and it didn't work. I don't know, there's some. There's some mistake. I don't know what.
Zeros.
Yeah, but
Common
why?
zeros.
There was zeros before.
Maybe expression was not correct.
But it was okay before?
It works.
It works at your computers, not at mine, so it's not so important that I show you, but it's just that you remember what you could do with these shares. So now you can make a chloropleth map and map all the shares of foreigners. So that should be okay. Okay, next tool in your toolbox. That's probably also interesting for a lot of you. Calculate distances between, for example, respondents that you have and some kind of features of the surrounding. So, and distances are an important determinant of social action. They can be calculated with the GIS. For example, the example that we do now is how far do the respondents, these are all the yellow points the respondents in constants, yeah. How far do they live away from the next cinema? Huh? Cinema, German Kino. Mm-hmm. All right. We have two shapefiles. One in this data folder that I gave you. One is individuals. That's the shapefile we had yesterday. Yeah, all the individuals. Maybe I zoom in a little bit. Right, and then we have a different shapefile. It's called Kinos, cinema, and we can add it to our map as well. And you don't see it here, but I know there are three cinemas in Constance. One is here, one is there, and one is there. So maybe we can show it better by making it larger. Okay, the style should be in a larger size and maybe a different color.
I think kinos.
So now you see it better. Now it's very large cinema, but okay. And now what we want to do is to calculate the distance from each of these inhabitants of Constance to the next cinema, and that's something what we do with this different, like you have to go to the vector menu, then the analysis tools, and then you have to analyze a distance matrix. Vector. Have you all added the individuals and the Kino shapefile? I will wait till you also. Yeah, very good. Okay, now analysis tools, and now we need to use the distance matrix. Here it is? Distance matrix. So now you could calculate the distance from each individual to each cinema or to the next cinema. And it's usually, when you have a lot of cinemas in a city, then it's probably not useful to calculate to each and every cinema, but only to the closest. So okay, now you have this window, and as you see here on the right, there's always some kind of help, and you can always and there's some help on the top, so you can always look for it. But you want to calculate like individuals as input point layer, and the target would be Kino's cinemas. And you need a unique ID field. This is, I tell you, I don't know why it's not sorted, but it's the AID. This is the ID of the individual shapefile layer, and the target would be some name. This is the name of the cinema. So you in order that the calculation works, you have a unique identity. You have to have a unique identifier, which we have here, and this is all good. So, and then you want to have a linear matrix type, I think, and you want to use only the nearest one target point. If you do the nearest two, then you have two distances. But this is for the time being. Is everyone still on board?
I'm just blind a little bit. Can you please tell me what you chose in the second one?
AID is AID stands for address ID, and this is the unique identifier in this shapefile. It's just a convention that we chose. You just need one identifier. Let me show you.
No, everything is fine. I have all the version of TJS and
okay.
the menu is different.
Yeah, it is. That's correct. Okay, now we click on run, and then everything should work. Needs not so much time. And you see, now we have a distance matrix. This is a new layer in our map. It's not shown, but it's just a table, the distance matrix. And when we open this distance matrix, by open attribute table as we did before. Then now we see a list of the input ID and the target ID, which is like all the respondents that we had, the closest cinema, and the distance from the respondent to the cinema. And with this kind of information you can work, you can go on, you can merge it again to your data set or do whatever you like. So, for example, respondent number 11390 lives 3.7 kilometers. This is in meters, as the coordinate system is, it can be whatever it is. 3,723 meters away from the Scala cinema in Constance. So, and you can imagine that you can use this kind of operation for a lot of different applications. When you have respondents that live at a certain address, you could calculate the distance to the center of the city, to the next postal office, or to the next pub, as you wish. So in my dissertation, I had one finding that was that people who live closer to bars and pubs are more integrated into the city than people who live farther away from pubs. So one recommendation for politicians would be to fund more bars and pubs in cities, maybe with cheap prices, and then the integration succeed between everyone.
Pubs connect people.
Yeah, exactly. And playgrounds, but playgrounds only for people with children, apparently. So, and what's also very helpful for integration is having a dog. Owning a dog is also very good. Yeah.
Can you make those dots different colors depending on to what cinema they're the closest to?
Yeah, you can. You can. Maybe we do this in a short while.
Okay.
Because we need one more tool. Because now we have the information of the distances not connected to the dots, but it's just in a table. And that it's the table distance matrix. And now we have to connect the table distance matrix to the individuals again.
I say I could not change color of individuals depends on distance, because it's a different table, so could aggregate.
Yeah. That's what she asked, but we will do it in a short while. We need some more tools in our toolbox first. The next thing we can do is that we aggregate data based on some spatial units. And the units have to be defined in a polygon shape file. So for example, how many respondents are in each neighborhood. But you can also easily find more research questions like how many crimes are conducted in each district, or how many schools are in each city. So as long as you have like districts or areas, and then you can calculate some measures of aggregation, which can be counts or means or whatever you like. And you do this with the data management tools. So now we have here the respondents in the neighborhoods, and now we want to calculate how many respondents are in each neighborhood. And we can do this by, I think, the data management tools, and it's called join attributes by location. You see, it's not always like, it's not so telling what it's called, but it's all on the slides. You can look it up if you don't remember. Yeah. So we join the attributes by location, and the target would be the neighborhoods, because for each neighborhood we want to know how many respondents are within these borders of this neighborhood. And the join vector layer then would be individuals. Yeah? And it's only calculated when the neighborhoods contain the individuals. You can do a lot of different analysis with these kind of things, because like when you have streets, then you can use the intersect, option, and you could for example calculate how many streets intersect with some kind of district, or what the mean length is of the streets that intersect in the district. So you can do a lot of things, and you can either take the attribute of the first located feature, then this is just added to this, or what we want to have is take a summary of these features that are contained in the neighborhood. And when we would use all these statistics here, sum, mean, min, max, median, then this would give us a statistic of all the fields of the individuals, like the sum of all the individuals of all the fields. So you see this gets really a lot of different fields. But we don't need all this. We delete it for now, so now we get only a count variable. But you could calculate the means, like the mean age of all the respondents in a neighborhood, for example. You don't have to. And another thing that you have to bear in mind is that when you only keep matching records, then it would delete all the neighborhoods where no respondent is in. So we keep all the records. So they are there because we have here neighborhoods. Because I scroll down, you don't see it, but you can remember that there are neighborhoods where there are no respondents. Okay, and when we run this, then we get a new layer. Yeah, it's a new layer of neighborhoods. And again, we can have a look. We open the attribute table, and no, there is probably a mistake by me again. So you see, we have a lot of different fields now. But what's the important field is the count field in the back, and this is the number of respondents. So this is something we could, for example, have a look again. We graduated, then we look at the count, we classify, we apply. So you see we have some neighborhoods where we have a lot of respondents, and we have some neighborhoods where we don't have a lot of respondents. So for our survey, this could have been a problem, that we have no equal distribution of respondents across the city. But it also depends, like, on the density of inhabitants in this neighborhood. So I think it's okay, the distribution that we have. We can also have a look when we pull the individuals on top. Like this, then we could check whether this all worked out perfectly. So, okay. What we can do now, again, and that's probably something we should also always do, is that we use the table manager not on neighborhoods, but on the joint layer. manager. And we could delete all the fields that I added, and I don't know why, but we could, for example, rename this count variable, just that we can remember what it is. Yeah? And maybe we rename it count respondents or something. So it's just that you by yourself know what you did, because when you look at this shapefile like in 2 weeks time, then you think, okay, what did I count in this shapefile? So what did I do? It's always good to use the table manager to clean out your shapefiles. Yeah? So I would, for example, because I made this mistake, I would just delete all the fields, and now I have a small shapefile again, and I can even save it not as joint layer, which is again very, I don't know, it's not very telling, but I could save it under a completely new name. All right. It's okay. Can we go to the next tool? Okay, when I don't hear anything, then I go on. All right. The next thing we can do is again spatial aggregation, because we can use this tool that we had right now to calculate not the distance to the next unit of something, like to the next cinema, what we did, but you can also measure how many units of one type are within a given radius around one respondent. So that's kind of individual neighborhoods, kind of. Yeah? So, for example, I calculated how many pubs or bars are within a distance of 200 meters around any respondent. And in order to do this, we need to establish these individual neighborhoods. So as we had before, we had these neighborhoods, now we want to have a circle around each and every individual. And for this we have to establish somehow, and it's when you have with the geoprocessing tools, you can establish fixed distance buffer. Yeah? So this is a buffer around each and every respondent, and you can do this for points, what we do, but you can also do it like for polygons or roads or whatever you like. So it's just now it's probably easiest. You have the individuals as input layers, and you want to have a distance of 200 meters. The segment is not so important, because this is just how it's displayed, and you run, and then you see a new shapefile. It's called buffer, and it only consists of the respondents that we had. Right? It's the same content, but now it's not points, it's polygons. Now it's individual neighborhoods. You see here, around every individual, there is one circle, but it's only a circle. When we don't show the individuals, then we see these are now all the individual neighborhoods, together with all the information of all the individuals. And now again, I can add some interesting feature of the surrounding, which is in this case the pubs in Constance. So now it's again green in green. I don't know why it always has the same colors. So I will red. So you see there's some areas in Constance where there is a lot of bars, and there are some areas where there's not so many bars. So, and now we want just to count how many bars are in each circle. That's something we can already do, right? And we do it again with the data management tool. Join attributes by location, and we join it as before. And now the target vector layer is not as before neighborhoods, it's this buffer shapefile. And we want to join it with pubs. We want to count how many pubs are within each individual buffer or individual neighborhood. Contain. No. And now it's important again that we keep all records, because otherwise a lot of respondents where there is no pub in the vicinity will be just deleted. Okay, we run this and we get a new layer. We open the attribute table, and now we see for each and every individual, AID is the ID, we see the count like this. For this individual, number 11360, there's 3 bars in the vicinity. Yeah? For others, like when the field is empty, there is no bar in the vicinity. But for others, there's 2, but there are even individuals who have 12 bars in a radius of 200 meters. So they, according to my theory, should be most integrated in the city. Yeah? Okay. Okay?
Yes.
Yes. All right. So now I come back to your very important question. How can we now display these kind of informations? And this is something you do by joining tables and shapefiles. So fields of a table can be combined with existing shapefiles. As with all the merging and joining, you need some kind of identifier, which we have. And now I don't use the example I had here. You can replicate it with the data you have, but I will try to show it to you with the data that we generated now. So we have individuals and we have the cinemas, right? And now we want to somehow display these distances of the individuals. And luckily we already have a table made from all the distances. So we have to combine the table of the distance matrix with the shapefile of the individuals. And we do this by right-clicking on the individual shapefile, we go again on this property window, and this property window, you see, you can do a lot of different things. We only have the style tab open, but also important is the so-called joins tab. And if you use the join tab, then you can add tables to this shapefile. And you add by clicking on the plus icon, and you want to join this distance matrix that we have. Distance matrix. The join field would be input ID, that this is the unique identifier, and this is the same as the AID that we had before. And this should hopefully work. Okay. Now we have a look at the individual shapefile again. And this is all the same. This is all the different fields and characteristics. At the end of the shapefile, this is the joined table. This is the joint distance matrix. So now we have for each and every individual all the information on the location, on different characteristics, plus the name of the next cinema, plus the distance. And this information we can use. So this join I have to add is temporary. So this is only for the existing session. If you want to have it forever, then you have to save this existing shapefile as a new shapefile, and then you have to have it permanently. So, but now we can use this information again in the Properties tab to have a different style. And now I have to have a look. No, it's a single symbol. Yeah, for example, when we have categorized, then we can use different cinemas. Okay, that doesn't look so nice. I want to have a different. For example, like this. So again, when you go on the style, property style, then you can either use categories. Categories would be like the next cinema in this case, or you can use some kind of graduated symbols, and I have to have a look, there's some kind of very nice okay. This needs some more work. So you see here, this distance is imported as a string variable, so we have to transfer it to a non-string variable, and then you can use it as a distance. But you get the trick. So we combine these tables, and then we can display it somehow in our maps.
But interesting, we selected categorize it, but not gradiate.
Gradiate?
Yeah, when we select gradiated, it will be, depends of the distance, will be different colors of individual.
No, what we did now is, or what I did, is to use categorize and the target ID. The target ID, as you can see in the attributes table, is the name of the next cinema. So, and we have 3 cinemas, so we should have 3 categories. I don't know why there's a 4th category. And based on these 3 different categories, I just assigned different colors. So you could also like use this distance, but as I said, it's not 100% easy because there is it's inserted as a string variable, so we have to somehow change this, but I'm not so sure how. Create a new field. We can use integer. Maybe we can do it like this. Okay, so I tell you again what I did, but now I first have to try it out myself. Okay, now this is probably what you initially thought would be handy, right? We have now graduated symbols that have a different color depending on how far the respondent is away from the next cinema. Was that something you had in mind? But you could not follow me, right? What I did.
Yeah, can you please show that again?
Yeah, okay. So the problem was, okay, but with the join we are already in the same boat. Almost. Okay. Okay. First step is you have this normal individual shapefile that we all already have. So first thing is you have to join this shapefile with the distance matrix. And that's something you do by clicking on the plus symbol and then I will remove this and I add join layer distance matrix join field. Okay, this is what you have. This is what you have to do.
Input ID, not distance.
No, this is just a join. This is just to merge the table and the shapefile. And for this, the program has to know which cases belong to which cases, and that's why you have to give a join field and a target field, which is just a unique identifier. And this unique identifier is called input ID in the one case and AID in the next case. This is just as it is. You just have to do it like this. Okay, when you all did this, then you nod, and then we go a step further, right? It's okay?
Yeah.
It's okay? Yeah. And those two guys do their own stuff. It's okay? Up till now?
Not everything.
We're on the way.
You're on the way. Okay, shall I wait some? No.
I already did it. But,
Okay.
but it's only one class received.
Okay. Then we can click OK. Alright. So what we do now is we have a look at the fields in this individual shapefile. And when we scroll at the very end, now there should be new fields. And for you, this should be two fields. This with all the names of the cinema, and this with all the distances. Yeah, did it work?
Yeah, but length is 0, I received, for example.
What is 0?
Length of the variable. What? I don't know why.
But is there no, is nothing in these variables?
Just a second, I have to look at yeah, there is distance.
It's not about the last field, it's about this field. Do you all have this field?
Distance matrix target. Or no, distance. Because I have null distance. Distance
You don't
matrix target.
Yeah, this is the field. This is this CE matrix. No, but it's no. This should be the same. Okay, this is the first 4022. This should be it's probably. No, this should be all right. So you're good to go.
Переінсталювати.
Yeah, maybe we have to.
Я ще не
later,
теж
right?
переінсталював. У мене стара версія,
Maybe.
через що відстав.
Должна быть.
Yeah.
Зайди.
Straight.
Томас моє?
Yeah.
This is because I have to reinstall.
Yeah. Okay.
This
Okay. Yeah, that's a table that you want to join, and then you need to know the identifier of the table and the shapefile. And this, in one case, it's input ID, and the other is AID. And this is all output A. So, yeah. And now you can have a look at the attributes table. Because that's where
Надо ж на маке совсем по-другому. У нас есть такая QGIS, и тут можно на меню.
I know what you calculated the distance from each neighborhood to each cinema, and not from each individual
Not
to
from
each
individual
cinema.
to cinema, okay.
Yeah, that's something we should have done.
Okay.
Okay, this was,
Should be into the
yeah,
and it's A.
yeah.
And how I select?
No, we don't have to show it.
Okay.
Okay.
Then
Okay, now I have a look at the, yeah, yeah,
no, I don't know why.
yeah, maybe you, now have a look at the distance matrix.
Hashtag remove.
How should I use it now? Did you use the cinemas as a second shapefile? Did you calculate it?
I don't know.
It all depends on what distances you calculate.
It means that it needs to recalculate.
Так, але процедуру
Vector geometry analysis distance.
Sure.
First should be.
Shall we maybe, so that not some are waiting all the time, should we make a break now and then we discuss individually what went wrong and what we can do?
And they calculate geometrical distance or distance
Euclidean
through I mean using
No, this is now like as
bars,
the crow,
using
as
some
the crow
some
flies.
robots and
Of course, this is the,
only geometrical, just like evaluation how.
yeah,
empty space distance.
empty spaces. And you can also, I guess you could also select Manhattan distance, which is for cities maybe a bit more precise. But for like more precise distances, you'd have to either use like a road network additionally, but then it gets very complicated. So, like for a course like this, I don't do it. What you also can do is use the Google Maps API
Google Maps or some other.
to calculate it.
Calculate the distance.
But Google will not like it if you do it for 1,000.
Yeah.
Now, a lot of you already did very good, and you see, the more you try yourself, the more you can do. You should just do it at least once, and then you can calculate a lot of different distances and whatnot. I want to end this session with QGIS and so on, now with some more comments, and then I will show you some data, and this will also provide them time to play around with the data or answer some more questions or something like this. Okay, the last tool that we need in our toolbox before we go to the statistical programs tomorrow is that you export your data. So we already had the tables, and the tables can be saved somewhere and then reopen with data or R or probably even SPSS. And this is pretty easy. You just right-click on the shapefile you wish to export, you save as, and you select as a format, you select CSV, which is comma-separated values, and this is a text file which you in turn can import in your statistical program. That's something we don't have to do now because we do it tomorrow. There are two add-ons for this. One is that a lot of the programs can also read shapefiles. GODA, Stata and R can do it, but it's not as convenient as. I would always suggest that you export your data as text files and then you have a clean file and that's everything's alright. And the other thing is, as soon as you have not points but polygons, so think of the the buffers, like these individual neighborhoods, then you don't have easily available latitude and longitude, because it's an area, it's not one point. And in order to extract the centroid, that is like the central point of this area, you can do it like this: menu vector, then geometry tools, then polygon centroids, and then it extracts you latitude and longitude of the middle of this point. And sometimes that's useful for your further statistical analysis. But that's something that I just wrote you on the slides in case you have this problem. Alright, so this was more or less the different tools that I wanted to tell you. One thing that we had here is that you can also change the language of the program with options, and then you have to override the default of the computer. So this is probably pretty handy. Okay, some general tips and tricks as conclusion for this first steps with geographic information systems. One, non-English characters can lead to problems. They don't have to, but they can, so it's better to avoid them. Huh? Second thing, missing values can lead to problems, so you have to fill them and you have to think about how to deal with it. It's not, these geographic information systems are not as flexible as all the modern statistical programs where you can just tell them the missing values and it will handle everything on its own. It's not that easy, and you have to at least think about it. Having not all layers in the same coordinate system can lead to problems that we know already. You should always check your results on a random basis. That's something you can do with the base map, and when you have data about Ukraine, you usually know where all the features are, so you can at least check a little bit where everything is. And the other check is what I did with all of you. When you did one operation, for example, the join command, then have a look at the attributes table, and then you will soon see what it is. When something does not work, it can well be that the field, which is the variable, has the wrong format, the wrong type. And this happened with the distance join, that we had it as a text field and we need it as a numeric field, and you have to translate it. But the field calculator can help you with this operation. And finally, when you're really interested in geodata, learn Python. Python is probably the programming language that can help you most. And for example, all these extensions and so on are programmed in Python, and you can do a lot of automatization with Python. How we as social scientists use geographic information systems is very different from how other users use them. So geographic information systems are built for geographer mostly, and they build on one map. So usually they just have one map, and sometimes they add a feature, and sometimes they don't. They remove a feature, because when in a city one house is built, then they add a feature or a tree or something. But we handle a lot of data, so it can be handy to automate the process somehow. And Python can help you with a lot of things, including web scraping, which is like getting data from the internet, which can also be useful for this. Okay. Now this was what I wanted to show you with the geographic information systems. Now I downloaded some data from Ukraine which could be useful for you, I think. and it's in your data, in your data folder. And I would suggest that we use like the next maybe half hour or maybe 15 minutes. You check the data I show you in a minute, or you try to figure out what we did in the last hour, or so we have a bit of free movement. Okay, the first source of the shapefile is this OSM boundaries map, and there on this website you can get all the districts, the data on all the districts in the whole world. And this, when you have administrative data, this can be very useful. I put it in your data file as well, because you have to register. You can use this this site only when you have registered with OpenStreetMap. It's not so. It's not difficult, and it's not. There's no hurdles. Everyone can register, but I don't. You don't have to register now, so I put it in your download folder, and you can just have a look. I think in Kiev there are like several different districts, and maybe this is of use for you. And there are other sources of shapefiles that you can probably use. Yeah, you can have a look yourself. And what I also did, what you can use is okay. Now we have a look at the data folder. So this is what we have here. We have the shapefile for Kiev, which is what I downloaded from this OpenStreetMap folder. But you can also, there are all the other districts in the Ukraine. Then there is another shapefile. I couldn't really figure everything out, but this is really detailed and has even neighborhoods and so on. It's in a different format, not in shapefile, but in GeoJSON format. But it's you can easily open it with your QGIS program. You do it like all the time. You add a layer. You want to add a vector layer, and then you just browse and open it. So admin level 5 maybe, and this is something that I don't know what it is, but you can always open the attribute table and there's some restriction. This is the...
No, nothing is. It's Sevastopol.
Yeah, I did not fully get all the data. I just thought I download some data and maybe you can use some districts, some areas or something else.
Can you please tell again what you opened?
You can always add layers
Yeah.
and add
What?
vector layers, the first thing.
Yeah.
And there you can...
So what did you choose?
I chose randomly from this Ukraine GeoJSON. I chose admin level 5, but I could have also used admin level 10, and then this would be something else. I don't know what's in this data. You have to look for yourself. And so these are like area level data, and then I put you on the USB stick this Ukraine latest free shapefile, and this is all data OpenStreetMap has about the Ukraine. So there are all houses and all streets and all rivers and all everything that's available open source on the internet about the Ukraine. So most other of these shapefiles are derived from this. So it's a bit hard to handle, but it can give you like a bit insight on what's possible to have, and maybe you can use some of these areas or features or something else. So you should just try it, and when you don't succeed, you just call me, and I will go around.
And all these shapefiles are already geocoded. Coordinates.
Yeah, but when it's a shapefile, it's usually with coordinates.
Usually unnecessary.
Usually.
Okay.